All right, break time's over. Part 2 coming at you. So we're solving natural logarithmic equations. Which the quick recap is, I'm trying to consolidate these two logs using properties of logs if they have the same base. ln is log base e. They match. Subtraction between logs of the same base yields consolidation with division. X divided by 2x plus 5. Again, watch the 4.7 videos if you are confused by that step. All right, keep in mind that the natural log is the same thing as log base e. The only thing that's going to undo that base e is the exponential base e. So on the left, you got this going on. On the right, you got e squared. I don't know if I want to make that a decimal just yet. I'm just going to hold out. I'm going to hold out and keep writing e squared, keeping in mind that it's a constant. So I can cross multiply here. That's 1x equals, okay, the e squared gets multiplied by both parts. So it's going to be 5e squared plus 2e squared x. All right. I'm probably going to have to do some moves here. You know what? I'll show you the moves where if you wanted to do this completely devoid of calculators, this is how you do it. But you can use a calculator to find the decimal approximations if you wish. So I'm going to get the x's together on the same side. And I'm noticing that I can't combine the 1 with the e squared. Okay? An e squared combines with the e squared. But what I can do is factor out the x. By factoring out the x, I'm left with 1 minus 2e squared. On the right-hand side, you got 5e squared. To get x by itself, you divide out by the constant it's being multiplied by. This is technically a constant. It's 1 minus 2 times 2.718 ... That's a constant number. So I'm going to divide on the other side by that same thing. And this is what x equals. X equals 5e squared over 1 minus 2e squared. Now let's think about this. If it's a negative number, then that solution's no good. I think it's a negative. Here's why. Let's see, 5 times e squared. E squared's a positive number, right? Well, 5's a positive number too. So the top has to be positive, yeah? E squared's a positive number, a big one. Not a big one, like probably somewhere around 8 or 9-ish. Negative 2 times that, 1 minus a number bigger than 1 is going to yield a negative value. A positive divided by a negative is a negative. A negative number cannot make this work. You can't natural log a negative number. That means there's no solution. Now, what does this look like if you were going full calculator on this? Well, I'm glad you asked. You get negative 2.681. And for that same reason, you should be able to conclude that there is no solution here because that's the only one you can obtain computationally. And if you guys knew how to graph these, then we would compare the two graphs to see that those graphs never actually intersect anywhere. All right. The last set of problems I wanted to lead you guys with is something I actually intended to do much earlier, but I really didn't. I don't know, I just didn't do it with you guys. I guess I was waiting for natural logs. But this whole idea that I can take a single or multiple logs and combine them together into something that's a lot more elegant than this clunkiness you see right here. Here's what I mean by that. Rewrite each as a single logarithm. You're thinking first about creating a clean log here and a clean log there, which means no coefficient. So this is natural log of 125 to the third power plus the natural log of 16 to the half power. You with me so far? Okay, now maybe instead of going through the rigmarole of figuring out what these are, I'm just going to combine these as I see them. So 2 logs with the same base that are added together, same base, both natural log, you'd multiply the result here. And this wow, okay. So 16 to the 1/2 is the same as root 16, that's 4. 125 cubed, that's a big number. Am I missing something here? I probably am. Oh my goodness. So, no. No, I don't think so. I think we just had an unfortunate incident here where, oh my goodness, that's a big number. Okay. Sometimes you get 7,812,500. Yeah. That's okay though. That's fine. We satisfied the condition. Write it as a single logarithm. That's a single logarithm. We did it. Let's try it with something hopefully more reasonable. Okay, clean log here would be 2 to the third power. Clean log here would be 4 to the second power. Subtraction between 2 logs of the same base means divide. Hey, this is a good one. So, natural log of 8 divided by 16 is the same as a natural log of 1/2. And this would be okay. All right, this answer, we could circle that puppy up and we would definitely be correct here. But watch this. Why is that significant? Because the log, no matter what base it is, of 1 is going to be 0. And 0 minus natural log of 2 is just the negative natural log of 2. So one might say that's a more elegant solution than this one. It's also kind of important when you talk about exponential growth, like growth and decay. This shows up a lot of times. It's 0.693. We just saw it on a previous example. So sometimes that's like a very healthy thing to have memorized. But you guys are kind of novices so far with this, so if you want to stick with the natural log of 1/2, you're free to do that too. All right, last one, number 8. If memory serves me correctly, 625, if memory serves correctly, 625 is a power of 5s. It's 5 to the 4th power. And 1/5 is 5 to the negative 1 power. I'm just thinking that's significant right up the bat. So now I can do natural log of 5 to the 4th to the 1/4 power minus natural log of 5 to the negative 1 to the 3rd power. And how do you take a power to a power and simplify that? Well, you just multiply. 4 times a quarter is 1. Negative 1 times 3, negative 3. I got subtraction between logs of the same base. I'm going to consolidate those through division. And then I'm going to use my properties of exponents to recognize that if I'm dividing two powers of the same base, then I'm going to keep that same base and subtract 1 minus negative 3 is 4. Is that right? I guess there's two different ways in which to express this. I could say that this is now 4 times the natural log of 5, or I could say it's the natural log of 625. This seems kind of off right now. I'm wondering if I made any mistakes in between. Here's what I'm going to do. I'm going to plug this in the calculator exactly as I see it. And I get this decimal. Can you guys see that? Now I'm going to do 4 natural log of 5. It's the same decimal. And I'm going to do natural log of 625. Ooh, same decimal 3 times. Nice. That checks out. I'm not sure which one you think is more elegant. This is simpler. But this is just a log that's completely clean. You be the judge. At this point, it's sort of the artisan's viewpoint. Okay? All right. That's all I got to say about, well, for now, it's all I've got to say about Euler's number E and how it relates to exponential functions and natural logs. Thanks for watching.